Okay, so this is the part 3 of the series of lectures for the chapter 7. In this part, I will be talking about price volatility of bonds with the embedded options. As you must remember that we have discussed that the value of a bond with an embedded option is comprised of two parts. So the value of bond with an embedded option. This is comprised of two parts. What two parts? One, it is the value of option free bond plus the value of embedded option. So one part constitutes the value of an option free bond, and the second part is basically the value of the embedded option. In other words, the value of a bond with an embedded option is equal to the value of an option free bond plus or minus the value of the embedded option. The two most common types of embedded options we talk about are the puttable bonds, callable bonds, which contain a call option, and puttable bonds, which contain a put options. Let's refer to the some graphs in the chapter and try to understand what will be the price volatility of these. Okay, let's first talk about the callable bonds. The callable bonds are the bonds with an option to the issuer that they can call the bond at any point in time. If you see in this exhibit, the convex curve A and A dash refers to the option free bond, and the curve AB, or you can say BA, AB refers to the callable bond. This unusual shaped curve is basically the curve for an callable bond. So the reason for this price volatility or the price yield relationship for a callable bond is that when the prevailing market yield for a comparable bonds is higher than the coupon rate on the callable bond, it is unlikely that the issuer will call it. So, for example, if this the coupon rate for a callable bond is, let's suppose, 7% here and here, and the market yield is, let's suppose, 12% here, the issuer is unlikely to call this bond at a cheaper rate and issue a bond at a higher coupon rate. So basically, since the bond is unlikely to be called, the callable bond will have a similar price relationship to an otherwise comparable option free bond. Consequently, the callable bond will be valued similarly as an option free bond. However, since there is still some value to this call option for the issuer, the bond would not trade exactly like an option free bond. It will be valued similarly, but it will not trade exactly in the same way. However, as the yields in the market decline, the concern is that the issuer will call the bond. The issuer would not necessarily exercise the call option as soon as the prices fall near the coupon rate or below this Y star, but the value of the embedded call option increases as yields approach to this coupon yield. For example, if the coupon rate, as I said, is 7% and yield declined to 7.5%, the issuer will most likely not call the issue. However, market yields are now at a level at which the investor is concerned that the issuer may eventually be called. Issue may eventually be called if the market yields further decline. In terms of value of the embedded call option, option becomes more valuable to the issuer, and therefore it reduces the price relative to an otherwise comparable. So as yields decline, as yields go near this point or below this point, the value of the option increases to the issuer. And as the value of the option increases to the issuer, the overall value of an callable bond declines. Okay, so let's move towards the main point here. So now let's focus on the exhibit number 11 in our textbook, which I have copied here. So this is the exhibit number 11. Here I have only put at the part of the curve from exhibit 10, which is here B minus B. So you are seeing only that part of the curve when it's more likely that the issue will be called. Okay, so we know from our earlier discussion just now that for a large change in the yield, the price of an option-free bond increases by more than it decreases. Right? Remember property number 4, that for a large change in the yield, the increase in prices is more than the decreases. However, this is not true for a callable bond. In fact, it is opposite. That for a given large change in yield, the price appreciation is less than the price decline. So here, this price appreciation from P to P1 is less than the price decline from P to P2. Right? So for the callable bonds, this phenomena or this relationship is true, and this is very important characteristics of the callable bonds, and it is referred as a negative convexity. What is negative convexity? Negative convexity is that price of a callable bond will appreciate less than decline when rates changed by a large number of basis points. But notice from exhibit 10 that callable bonds do not exhibit this characteristic at every yield level. So you can see that this characteristics is not true here. This is only true in this domain, not here. So when basically yields are high, related to the issuer's coupon rate, the bond exhibit the same price yield relationship as option-free bond. Therefore, at a high yield level, it has the characteristic that the gain is greater than the loss. But at a lower yield levels, in this domain, this is opposite. The price decrease or decline is larger as compared to price increase for the same basis point change in the yield curve, right? And we refer to this phenomena as positive convexity, and this is negative convexity, right? Okay, as can be seen from exhibits. So if I can show you this, so this is the negative convexity when bond is in a region when discount rates or the yield curve is very close to the coupon rate, and here it's the positive convexity region when bond behaves like a normal bond. And you can see from these exhibits, then when a bond exhibits negative convexity, the bond compresses in price as rates decline. So prices are compressed as rates go down. That is at a certain yield level, which is very close to the coupon rate of the issue. There is a very little price appreciation when rates decline. When a bond enters this region, the bond is said to exhibit price compression. So what is the price compression? Price compression is behavior of the prices of a callable bond in a region when rates are very close to the coupon rate, when price appreciation is very low when rates decline. That's what we understand of callable bonds. Now let me go back and discuss the puttable bonds. Okay, so what you see here is a price relationship for puttable bonds. Puttable bond. What is a puttable bond? It's a bond which may be redeemed by the bondholder, means investor, on the dates and put price specified in the identifier. Typically, the put price is set very close to the par value. The advantage to the investor is that if yield rise and the value of the bond fall, they can sell the bond at a par value to the issuer. However, if the put price is par value, this means that if the market yields rise above the coupon rate, the bond's value will fall below par and the investor will then exercise the put option. The value of the puttable bond is equal to the value of option-free bond. Again, the value of a puttable bond is the value of an option-free bond plus the value of this put option, right? And this the difference between the value of a puttable bond and the value of an otherwise comparable option-free bond is basically the value of the put. And this is only the value when yield approaches or the yields goes above the coupon rate. This Y star is the here is the coupon rate, right? So it's pretty straightforward. So in this at low yield levels, the price of the puttable bond is basically the same again as we noticed for the callable bonds. At low yield levels, price of a puttable bond is similar to an option-free bond because the value of put option is very similar. As rates rise, the price of the puttable bond declines, but the price decline is less than that of an option-free bond. So the price decline of a puttable bond is less than of an otherwise option-free bond, because the divergence in prices because of the value of that put option, that the prices cannot go beyond the par value. They cannot decline beyond that par value, right? So in this video, I have discussed very important topic of price volatility characteristics of option embedded bonds, and we have talked in detail about the callable bonds and puttable bonds. In the next video lecture, I will be talking about the measurement of that interest rate risk. Thank you.